NEC Table 250.122 specifies the minimum size of grounding conductors for various ampacities. For a 2500 amp service, the required grounding conductor size is 4 American wire gauge minimum or larger. Conduit fill calculations are important to determine the overall conductor size. Let's analyze the conduit fill and grounding requirements. From the transformer to the disconnect, there are 6 sets of 4-inch conduits, each containing 4 600 MCM conductors and 1 3/0 conductor. Each conduit contains 4 times 600,000 circular mils plus 1 times 331,000 circular mils of copper. The calculation is shown as 4 times 600 plus 1 times 331 to keep it simple to read, which equals 2,731,000 circular mils per conduit. So each conduit contains 2731 kc mil copper. The total copper area in all 6 conduits is 2731 kc mil times 6, which equals 16,386 kc mil. From the disconnect to the main distribution panel, there are 6 sets of 4-inch conduits, each containing 4 600 MCM conductors and 1 3/0 conductor. Each conduit contains 4 times 600,000 circular mils plus 1 times 331,000 circular mils of copper. The calculation is shown as 4 times 600 plus 1 times 331 to keep it simple to read, which equals 2,731,000 circular mils per conduit. So each conduit contains 2731 kc mil copper. The total copper area in all 6 conduits is 2731 kc mil times 6, which equals 16,386 kc mil. Based on these conduit fill calculations, the required grounding conductor size for each conduit is determined. For conduits up to 60% filled, where the copper exceeds 16,386 kc mil, the minimum grounding conductor size is 2 American wire gauge. For conduits 60 to 70% filled, where the copper is in the range of 16,386 to 20,167 kc mil, the grounding conductor should be 1 American wire gauge. For conduits 70 to 80% filled, where the copper is in the range of 20,167 to 24,048 kc mil, the grounding conductor should be 2/0 American wire gauge. Based on the analysis, it appears that the ground wire size in each conduit may be incorrect as per NEC Table 250.122. The minimum required grounding conductor size should be 2 American wire gauge or larger, depending on the actual conduit fill. It's important to verify the actual conduit fill based on the specific wire sizes and conduit dimensions to determine the correct grounding conductor size. Remember to consult NEC Table 250.122 and perform accurate conduit fill calculations to ensure compliance with electrical codes. The table provides guidance on the minimum size of grounding conductors based on the size of the ungrounded conductors. Always prioritize safety and adhere to the latest edition of the National Electrical Code. It's recommended to consult with a qualified electrical engineer or inspector to verify the grounding system design and ensure compliance with all applicable codes and regulations. Consider the following points when determining the appropriate grounding conductor size. Firstly, calculate the total circular mil area of the phase conductors in each conduit. This involves summing the circular mil area of all conductors, including phase conductors and neutral conductors, if present. Secondly, determine the percentage fill of each conduit by dividing the total conductor area by the internal area of the conduit. The internal area of the conduit can be found in the NEC Chapter 9 Table 4 or from conduit manufacturer's data. Thirdly, based on the calculated percentage fill, select the appropriate grounding conductor size from NEC Table 250.122. The table provides minimum grounding conductor sizes for various ampacities and conduit fill percentages. Grounding conductors play a crucial role in electrical safety by providing a lower impedance path for fault currents to return to the source. Proper grounding helps to minimize voltage rise during fault conditions and reduces the risk of electric shock. The size of the grounding conductor must be adequate to safely carry the maximum fault current that could occur in the system. Oversizing the grounding conductor is generally acceptable, as it provides a lower impedance path and enhances safety. However, it is essential to avoid undersizing the grounding conductor, as this could compromise safety and potentially damage equipment. The National Electrical Code provides specific guidelines for sizing grounding conductors to ensure adequate protection. It is important to carefully review and apply these guidelines in all electrical installations. In addition to sizing the grounding conductor, it is also important to ensure that the grounding connections are properly made. Grounding connections should be mechanically sound, electrically conductive, and corrosion resistant. Improper grounding connections can introduce high impedance, which can impede the flow of fault current and compromise safety. Grounding electrodes, such as ground rods or ground plates, must be installed in accordance with NEC requirements. The number and spacing of grounding electrodes depend on soil conditions and other factors. The grounding electrode system should provide a low impedance path to earth, which helps to stabilize voltage and protect against ground faults. Regular inspection and testing of the grounding system are essential to ensure its continued effectiveness. Grounding connections should be checked for tightness and corrosion, and grounding electrodes should be tested for proper resistance to ground. Any deficiencies should be promptly corrected to maintain the integrity of the grounding system. The goal of grounding is to provide a safe and reliable electrical system that protects people and property from electrical hazards. By following the guidelines in the National Electrical Code and employing best practices, electrical professionals can ensure that grounding systems are properly designed, installed, and maintained. The importance of proper grounding cannot be overemphasized. Grounding is a critical component of electrical safety and plays a vital role in protecting against electric shock, fire, and equipment damage. Electrical professionals must be knowledgeable about grounding principles and practices to ensure the safety and reliability of electrical systems. Remember to consult with qualified electrical engineers or inspectors when designing or installing grounding systems. These professionals have the expertise and experience to ensure that grounding systems are properly designed and installed in accordance with applicable codes and regulations. Grounding is not a one-size-fits-all solution. The specific grounding requirements for a particular installation depend on various factors, including the size and type of electrical system, the building structure, and the environmental conditions. A thorough understanding of these factors is essential for designing an effective grounding system. Properly sized grounding conductors and properly made grounding connections are essential for the safe and reliable operation of electrical systems. Always prioritize safety and follow the guidelines in the National Electrical Code when working with electrical systems. Ignoring or neglecting grounding requirements can have serious consequences, including electric shock, fire, and equipment damage. It is important to take grounding seriously and to ensure that grounding systems are properly designed, installed, and maintained. Grounding is an investment in safety and reliability that pays dividends in the long run. By prioritizing grounding, electrical professionals can help to protect people and property from electrical hazards. In summary, understanding and applying NEC Table 250.122 is crucial for correctly sizing grounding conductors and electrical services. Careful attention to conduit fill calculations, conductor sizing, and grounding connections ensures a safe and compliant electrical installation. Always consult the latest edition of the NEC and qualified professionals for specific project requirements. The information provided here is for educational purposes and should not be considered a substitute for professional engineering advice.